So good morning, everyone. So we continue with the last session on laws of motion, and we'll deal with topic of friction. We started with friction yesterday, and we continue with the same. Okay, so let's look at some of the examples of friction. So question is there on the screen. So all of you look at this, and this question, okay. This is a case where this triangular block is fixed. This is not in motion. Okay. And there's a pulley. One block is connected like this. There's another block connected here. Mass of the block, this block is given as 10 kg. Coefficient of friction is equal to 0.2, kinetic friction. And this can slide on the surface, angle is 30 degree. If a block A slides down the incline at a constant speed. So what is it? It is moving down the slope. And moment it is moving, what kind of friction? It has to be kinetic friction. So first case is when it is moving down the slope at a constant speed, what has to be the mass of B here? That's what we need to calculate. What mass of B will make this situation possible? So let's analyze this question here. And whenever we come across a question where it is connected with the string and pulley and a single string, and all objects have same magnitude of acceleration, we can make it a kind of, we can draw the free body diagram, then we can make it a straight line. When you make it a straight line, it becomes simpler. We can solve the question faster. So first, I hope if it is moving down the slope, if we mark the direction of motion, what is the line of motion? This is the line of motion. If I draw the motion, this is the line along which object is moving, and this is down the slope, and this is along the line at which it is moving. And we know we have done something similar before, so we'll mark it. So what we'll do here, we'll take the component of forces along the line of motion. Let's say what are the component of forces, what are the forces acting, and then take the component. Here, which force is acting? Mg is acting downwards. What will be its component here along the slope? Component of force here along the slope will be equal to mg by 30. Yeah, some of you have this audio on, please switch it off. And this force will be internal, I will not mark. And what other force will act other than tension? Since it is sliding downwards, friction force will act here. Friction force will also have a component along the line. How much will be the friction force? Friction force will be equal to mu mg cos 30. Okay, and then there's a tension here, and there are also same tension T here, and then here mg here, which is, that's what we need to find here. Let me call this m0g or mbg here. And that's the forces acting. So again, to simplify this question, once we mark the forces, now we can represent whole thing as a straight line. If we represent, so that's what we are doing. So I have marked the component of forces along the straightened line of motion. We have taken the components. And what is the kinetic friction here? Kinetic friction, let's mark these values also. 0.2 into 100 into cos 30 is 0.87. So this force comes equal to 17.4 tons. So what here, this is, and then we have mg, this value here, mg sin 30. Okay, sorry. So this is 30 and mg, how much mg sin 30 will be? This is 10 to 100, 100 by 2, this will be equal to 50 Newton. So these are the forces acting. Let's draw in a straight line version. In a straight line version, these are the forces. The forces will cancel out. This is how it will look like. And it has zero acceleration. If it has zero acceleration, very easily you can notice this force mg has to be equal to 50 minus 17.4, which is 32.6 Newton. And it is 32.6 Newton, or we can say roughly 33 Newton. If this is 33 Newton, the mass has to be equal to 3.3 kg. So that's how we can solve. You notice here, very quickly you can get an answer. So this was the first part. What is the second part? Second part, what should be the mass of B if A slides up the slope? So what will the answer be same? Will the same mass? Even when it's sliding up also, even then also acceleration is zero. But something will change. What will change compared to when it's sliding down? What will change here and why should answer change here? What
Direction of friction of force will change.
Direction friction will reverse. Yes. Only the moment I say it is sliding upwards, since the direction motion is upward, Friction force magnitude will remain same. It will remain as a kinetic friction. Its direction will reverse. So when I'm solving part B, this direction will become reverse. And if the direction becomes reverse, this value mg will become 50 plus 17.4, 67.4. And 67.4, it means mass is equal to 6.74. That's what the change in the answer will be. So notice this guy, how quickly we could get an answer here. Action force will change. Next question is something like this, which if you pay attention, many of you might have observed this. See, if just imagine there's a conveyor belt, which we can see in the airport and all. If conveyor belt, and typically you'll find the conveyor belt keeps moving at a constant speed. Let's take the straight portion of the conveyor belt. It is moving at a constant speed of 3 meters per second, which is very, very high. So it is this very fast conveyor belt. It is used for some other purpose. And if we drop a suitcase, you notice you can come across different kind of suitcases. Some suitcases have a very hard and smooth surface. Some suitcases are made of a cloth kind of material. So different suitcases will have different coefficient of friction. And coefficient of friction is a property of two surfaces which are in contact. So different suitcases may have different coefficient of friction. So let's take in this particular case, coefficient of friction is 0.5. And if we drop a suitcase, if we just place the suitcase on the belt, as soon as we place the suitcase on the belt, this will have a velocity equal to 0. That's what we mean. Initial velocity of this suitcase, as soon as we place it, is 0. Whereas the conveyor belt is moving at the speed of 3 meters per second, it means slipping will take place. When the slipping takes place, the question is, yes, so belt will move faster. So if I take a particular point, so if I mark 2 points here, what are 2 points here? One point I mark A. Point A is on the suitcase. Point B is a corresponding point in contact on the conveyor belt. What I find here, A has 0 velocity, B has positive velocity, and B is moving the constant speed. Hence, B will move ahead, A will fall behind. So there's slipping taking place. The question is, find the displacement of suitcase relative to conveyor belt before the slipping between two is stopped. So what does it mean? After some time, see, this also, will it always have 0 velocity? If the friction was 0, this suitcase would have remained exactly at the same place. So if you stand here, you have dropped the suitcase. If the coefficient of friction was 0, if you drop the suitcase on the conveyor belt, suitcase will remain right next to you. It will not move. But this particular case, we know there's a coefficient of friction, and friction force will give motion to the suitcase. It will make the suitcase move. Let's see how would that motion take place. So if two surfaces in contact are moving with unequal velocity, slipping will take place. This is the case here. One velocity is 0, other is 3. What friction does? Friction will tend to make the velocities equal. So what we'll do, how does it make it equal? It will tend to increase the velocity of object which is moving slower. That's why you can another way to understand which direction the friction will act on the suitcase. On the suitcase, friction will act in the forward direction so that it will speed up the object which is slow, and will act in the backward direction on the conveyor belt. But conveyor belt is conveyed, but there's an external force also acting. So even if friction force is acting, this velocity remains unchanged because of some external force acting in place of conveyor belt here. So this, in this case, you notice, so this will have a force acting, and this force, will this force be a constant force or varying force? What kind of forces? This is kinetic friction. And kinetic friction does not depend on velocity. So as it gains velocity also, the magnitude of friction will not change. And since the magnitude of friction is not changing, it will undergo constant acceleration. So it will have motion which is under constant acceleration. And let's calculate here. And so we understand here one more way. There's one way we can understand is whenever two velocities are unequal, friction force will act on the two objects so as to make it equal. It will increase the speed of slower moving object and tend to decrease the speed of the faster object. Second, we can understand in terms of relative motion. I'll come to relative motion again. Relative motion in terms of direction. So fairly easy. If there's a relative motion, kinetic friction will act on the suitcase. And what will be the value of force? Force will be equal to mu mg, or suitcase will have forward acceleration. And how long it will have? So it will have zero velocity if force is acting. At some point in time, let's say what has happened by the time the suitcase has reached here, it has velocity has gradually increased. And here, by this point, v has become equal to 3 meter per second. Now question is, now the slipping there's no relative motion. Will the friction still act, or will friction come to stop here? Moment slipping stops. See, if we keep any superimage, so moment both velocities become equal, there's no reason for friction to act. So moment velocity becomes same, the friction stops acting. So this is the point friction stops acting. And now the belt and the suitcase will move at the constant velocity. But by then what has happened? The point A has moved here. Point A has been gradually accelerated from 0 to 3. But B had a constant velocity 3 meter per second. So this is the point B on the conveyor belt, which was initially in contact with the suitcase, has reached this point. So what is the displacement of suitcase relative to the conveyor? If I look from the frame of reference of point which was in contact, which is B earlier, the suitcase had a negative displacement of this much. The suitcase has fallen back by this distance. That's what we need to calculate here. Okay, so we spent so much time to understand what happens, what is friction, when does it come to stop, which direction it acts. Okay, so when until it acquires same velocity as the conveyor belt, and then the friction ceases to act. So you notice it when in the train also, when the train is running at the constant speed, if suitcase is lying on the train surface, no friction is acting, because so if we want to understand same thing in terms of relative velocity, let's understand here. There are two surfaces A and B which are in contact, and if both are in motion, if both are moving a velocity of 3 meter per second, so if I look at B also, just imagine it's like two cars also. If two cars are moving together side by side with speed of 3 meter per second, to A, B also appears to be at rest, and to B, A also appears to be rest. There's no relative motion, and the friction will not act. Now let's take the second case here. This car is moving with a 5 meter per second, and BB is moving in the same direction with speed of 3 meter per second. As I see from A, you just see, imagine you are sitting in the forward faster car, B will appear to be moving backwards. So what is the relative motion of B as seen from A? The relative motion of B is backwards. Hence the friction force on B will act in the forward direction. And if you see from B, A is moving faster, means A will appear to be moving forward at a speed of 2 meter per second. So relative motion of A is forward, hence friction force will act on the backwards. So the direction of friction force is opposite to relative motion. So that is in terms you can understand in terms of relative motion, or I think it's even better, I feel is more convenient. It will act in the backward direction on the object moving faster. It will act in the forward direction on the object which is moving slower, which will tend to make the velocities equal. So it is always a pair force, always forces always exist in pair. Friction force will act on A, and whatever friction force acts on B, A equal and opposite will act on B. Let's take the third case. When this is moving at 3 and this is moving at 5, so again it will reverse. So that is something how do we understand direction. Now let's come back and solve this question. And fairly simple only, I think understanding is okay. Once we understand, rest all is very simple. Displacement of suitcase unit until it reaches speed of 3 meter per second. So what is this case given here? U is 0. And A is equal to, what is acceleration here? Force is equal to mu mg, hence acceleration is mu g. So we'll notice here, any object, it is getting accelerated only because of friction, and acceleration will always be equal to mu g, and mu value is 0.5, so it has acceleration of 5 meter per second square. So if you have to calculate how much time it will take, what will the duration of acceleration, it will have duration of acceleration will be only 0.6 seconds. Only for 0.6 seconds it will accelerate. So time for acceleration, though it is not required here, if I have to calculate time for acceleration will be equal to 0.6 seconds. So what is the displacement? Displacement also I can calculate 1 by 2. We can calculate the acceleration 1 by 2 at square, or I can calculate displacement is equal to average velocity. Average velocity is 1.5 meter per second and time is 0.6. Thus the displacement of the suitcase, which is equal to 0.9 meter. So what has happened? The suitcase, by the time velocities become equal, it has traveled 0.9 meter. How much distance the belt has traveled in the same duration? Belt has traveled 0.6 into 3, 1.8 meter. The relative displacement is 0.9. Okay. We could have done it different way also. Different ways from the frame of reference of the conveyor belt. In the frame of reference also we can write what is the initial velocity of the suitcase and what is the relative acceleration of the suitcase. We can do from the frame of reference of the conveyor belt. Somehow we can try that also very quickly can arrive at the answer. Next question. Coefficient of friction between block A, mass of 2 kg. So block A is mass of, it has mass of 2 kg. And coefficient of friction is 0.2. What we need to find here, what is the, if we suspend some mass here, this mass will tend to move downward. It will try to make the block A also move. But because friction is present here, friction will resist its motion. So what we need to find, what is the maximum value of block B? What is the maximum value of mass? Okay, what is maximum value of mass of B? So that two blocks do not move. Okay, so if the mass is very small, yes, it makes sense, it will not move. As we keep increasing mass, there is a maximum cap on the mass of B, beyond which if I increase the mass even slightly, the blocks start moving. Okay, so this is like a hanging weight. So what is the condition? Whenever you come across a question, maxima, minima, this question always involve one kind of friction. What kind of friction will act here? What is the condition of motion? Whenever maximum, minima is involved, it is on verge of sliding. So any slightest increase in mass of B will make this block A slide and B also move. That's called limiting state of friction. So what will be condition here? Friction will be maximum value. Friction acting here will be maximum value, and limiting friction, friction is max and acceleration is still 0. Okay. So in this case, what is maximum friction here? It's very easy to solve. And we see this same principle is applied in several other cases also. So when I talk of maximum, how much is maximum friction? Mu, it is mu times mg. So which is equal to weight on the horizontal surface. So this becomes equal to 0.2 into ma into g. And this has to be equal to, since this is the tension, friction force will be equal to tension if I analyze only block A. And same tension acts on block B. And since acceleration is still 0, it is equal to mb into g. So what is the equation we get here? 0.2 into mag is equal to mb into g. And what we understand here, another way to understand is mu times weight on the horizontal surface is equal to hanging weight. Mu times weight on horizontal surface is equal to hanging weight. And this question, it comes in form of a chain. So chain question also works on a very simple principle. Okay. That's what it is. Okay. This is how the free body diagram will look like. This is how the forces will look like. T is equal to mg, and this is a condition we have here. And this condition, see, same question, we can slightly reframe it. How do we reframe this question? Just look at this. Suppose we have a tabletop which is rough. It has coefficient of friction between this surface and there's a chain line here. Coefficient of friction between the chain and the tabletop is mu, and length of the chain is, total length is L. So we know here the question sometimes come, what is the maximum fraction of chain length which can be hanging? So what is the maximum fraction of chain length which can be hanging and still it is in rest, still in rest? So if is this question identical to almost this question? Here this entire mass of the chain is equal to ma, and this hanging mass is equal to mb. So if I say the fraction is equal to alpha, this length is alpha L, and this will be equal to 1 minus alpha L. So what is the equation I can write here? Same way if I write mu times this weight, mu times 1 minus alpha L into G has to be equal to hanging weight, which is equal to alpha L into G. So any length is given also, we can easily solve. So the hanging chain question and this question are identical. Let's come to something like this. This question also comes in different forms. One form is like this, and I'll come to some other form. This question is there in several other books. Though theoretically this question looks a little weird, but still we'll solve it if it is given in this form. How do we solve? A system, see, suppose these are the masses here. If we do not apply any force, it makes common sense. This block, which seemed to be hanging, will fall downwards. It will not stay where it is. But what this question says, if we apply a force, what is the force, which minimum force what we need to apply here so that this block does not slide downwards? And what is preventing this downward motion? Friction is preventing downward motion. So there has to be friction either on both the surfaces or at least on the one surface. There is a friction here in this question. What is given? Friction between B and C is mu. So where is the friction present? Friction is only present here. So what happens earlier when the no force is applied? It slides down. Why the friction is not preventing its downward motion when force is not applied? Can you think of reason? When force is not applied, why it is friction is not preventing its downward motion? Because when this external force is not applied, when you look at these two surfaces, the normal reaction, the surfaces which are in contact are vertical. So normal reaction has to be horizontal. So there is no normal reaction acting between these two surfaces. Hence the friction force also is zero. That's why the block, nothing is there to prevent its downward motion. What happens when moment you apply a force here? Moment you apply a force up here, there's a contact force between these two blocks, and there's also contact force between those two blocks. And those contact forces are horizontal, which act like a normal reaction. Greater is the force we apply here, greater is the normal reaction, and greater is the maximum possible friction force. So what is the minimum force? Again, moment we talk about minimum force here, in case of minimum force, whenever we talk of minimum force here, friction acting will be equal to limiting friction and acceleration is still zero. That's the basis we will solve. So if I look which system are we concerned with here, we are concerned with motion of block B. So let's take free body diagram of block B. What are the forces acting on block B? At this point, there's a contact force acting. And this force is actually pushing mass 3m. This force will be, the contact force will be equal to 3 by 5 or total F. And some of you can follow. And this force here, the contact force here between m and 2m is giving acceleration to mass 2m. And this F is for total 5m. So this will be 2 by 5 F, 2F by 5. We can easily arrive at. So this is a normal reaction here. This is a normal reaction at this surface. Its weight mg is acting downwards. And since there is a normal reaction here, friction force acts, and we have taken a limiting state. In case of limiting state means it is on just verge of sliding down. If I drop a grain of sand on the top, it will start sliding down. That's what it means. Slightest increase in this part here, the force which is tending to slide the block down, will make it slip. So what is the friction force? Mu times normal reaction, F max. And it is still in the equilibrium. It means this force is equal to mg. So that's my condition here. That's the equation for is Alan.
Sir, is there any force which is preventing it from rotating, sir?
Yeah, that's why I'm beginning as said. Is this question make sense? No. See, if you there is some force acting, there's some force which will prevent this rotation. But what force will act, that I'll deal with when we come to rotation. Okay. So yes, there's some force which can prevent its rotation. Only thing what has to happen, ideally it should not be too narrow. It should, height should be more. But yes, it's possible. Some forces do act, and that will prevent its rotation. But if this question is given, I will not bother about rotation. When it comes to rotation, we'll understand how does it happen. Okay, so that's the condition, limiting state. I know somehow my order has gone wrong today. Okay, coming to next question. So we are all through different types of question. We are understanding what are the different ways questions related to friction can be presented, and each case basic principle remains same. We need to learn how to apply. So all questions have select something little different, and pay attention to what is something new we can learn, and make sure those things are well understood. So this case here, a block A of mass 2 kg is placed on inclined plane, and unless it is mentioned, whenever inclined plane is mentioned, we assume that this plane is fixed, unless there's some indication that it's going to move. Okay, so it's placed in the shown, and coefficient of friction is 0.5, and this angle is 30°. So if we do not apply any force here, will this block slide if angle of 30°? How do we check whether it will slide or not? What is the critical angle at which it will slide? Critical angle is equal to tan theta c. If the angle is equal to tan theta c is equal to 1/2, it will slide. It will be on the verge of sliding. So if theta is greater than theta c, or if tan theta is greater than tangent of theta c, or tan theta is greater than mu, it will slide. Is it greater than mu? Yes, because in the denominator, 30° is 1/√3, 1 divided by, so tan theta is 1 divided by 1.73, where mu is 1 divided by 2. This number is greater. So if we just place the block here on the surface, it will have a downward acceleration. I think someone should follow this part also. But we can prevent its motion in various ways. What is given in this question? What is the minimum normal force F we need to apply in this block to prevent its downward motion, to prevent it from sliding downwards? So again here, what question here? What is the minimum maximum? So whenever you come across a question, something which involves maximum minimum, again we take two things in mind. Is limiting friction will act. Limiting friction means friction is equal to maximum friction and acceleration is still 0. If you apply those things, we can easily find an answer. So in this case also, if I draw free body diagram of this object here, because this object which is relevant here, what are the forces acting here? Mg sine theta. Wait, first of all, we have resolved all the forces along x direction and y direction. And all such cases, it makes more sense to take x-axis along the slope. And what other forces are acting here? Mg cos theta, mg sin theta have resolved two components. N is anyway acting along positive y-axis. So this is N here. And this is F acting here. Is N equal to mg cos theta? No. In this case, N will not be equal to mg cos theta. And the friction force will act in the opposite direction. So first what we need to do here, in this case, first we need to find maximum friction force, which is mu times N. I need to find the N first. And how do we find N here? If you recall, Y I can also write as Y is nothing but normal direction. How do you find normal reaction? Normal reaction is a self-adjusting force, which makes the normal acceleration to be 0. So we can find the value of N using summation of force in y direction to be 0, which gives you N value is equal to mg cos theta plus F. So application of this force, whatever force we apply here, there's a corresponding increase in the normal reaction if it is perpendicular to the surface. It has effectively increased the normal reaction. And what is the effect of increase in normal reaction? Since friction force is maximum friction force is mu time normal reaction, by increasing N value, we have increased the value of friction force. So in the limiting state, the maximum friction force has to be, acceleration is 0. So mg sine theta has to be equal to F max, which is mu times N. So that's my equation. Now let's put the value. Rest all is pretty simple. So mg sine theta, 20 into 0.5, this becomes 10. Mu is equal to 0.5, and N is equal to, mg cos theta comes equal to roughly 17.7 plus F. We can find the value of F. So this also I hope most of you all are finding it pretty easy. Okay, so if something you find a little tricky, Go back and revise and make sure that all are understood. They are very simple question. Now let's next question. You can all read the question and then we'll go about solving this question as well. See, if this is a question again, upper half an inclined plane with inclination of phi. So angle of inclination is given. Upper half is perfectly smooth, while the lower half is rough. So the two parts here, half. Bodies start from rest at the top. Since the top friction is zero, it will have a downward acceleration and it comes to rest at the bottom. It means when it is moving in the rough part, it is again getting retarded or it is suffering deceleration. So what is the coefficient on the lower half of the inclined plane? Of course, the answer has to come in terms of phi, which makes it possible. So first of all, let's try and understand what the question is. If I have to visualize this question, it is like this. This is an inclined plane. And if inclined plane total length is L, so this part is half L by 2, this part is L by 2. And upper half here is smooth, lower half is rough, and it has certain coefficient of friction, mu. And this is L by 2. And if you I give you a hint, this question also can be solved in less than a minute. How do we solve in less than a minute? If from here it accelerates for certain distance and there's something retardation or deceleration. So here, if acceleration direction is like this, A1, and here direction of acceleration has to be like this, then only it comes to a stop. So retardation and acceleration. And do we have a relationship between A1 and A2? Are these two quantities related magnitudes? Of course, directions are opposite. Since it accelerates for same distance and decelerates for same distance, magnitude of acceleration and deceleration has to be equal. We have done this question twice so far in last 15 days, and try and recall, we have done in kinematics and we have dealt with something later also. So you want to understand quickly, yes, we can write in from equation, the distance traveled is proportional to, we do that one. How to use the condition as distance of acceleration from rest is equal to distance of deceleration to rest. It implies the magnitudes are equal. And in this case, acceleration is downwards, which is equal to g sine phi. Here, the acceleration is upwards. Why the acceleration is upwards? Force which is acting in the upward direction must be greater than component of force in the downward direction. Okay. So if we write acceleration, which is the force acting in the upward direction? Friction force. One is acting in the downward direction is mg sine phi. So when I write what is the here, so in terms of this is acceleration, so I divide by m. So which one I write first? I write the friction force minus mg sine phi. So this would be the retardation. So equate those two, I get my answer very quickly. What is the answer now? Pretty simple. So g sine phi. Yes, Vignesh, any question?
So, like, can we do this using work energy theorem?
You can do with work energy theorem also. Let's see how do we write in terms of work energy theorem. And how do you write in terms of work energy theorem? If I take this as initial point and if I take this as a final point, what is the change in kinetic energy? Start from rest, come to rest here. So change in kinetic energy is equal to 0. And change in kinetic energy is equal to work done by all forces. And anyway, so this we are going to deal next week anyway. What are the two forces which are relevant here? The work done by force, work done by gravity plus work done by frictional force. So if I call this length of the inclined plane as L, work done by gravity will be equal to positive. Work done by gravity is equal to mg into vertical displacement will be equal to mg into L sine phi. And what will be work done by friction force? Friction force will be negative. Friction force is equal to mu mg cos phi, and it will be equal to into L by 2. That's also we can write. So since we have not come to the topic of work energy, work power energy, is this clear?
Yes.
So we could have done from that perspective also. This is what work done. Work done. We take this vertical component here, and yes, the friction force and displacement are opposite to each other. And some of you wonder what happens to gravity. We have taken the effect of gravity right through. We have taken mg into L sine theta. So as it moves from here to here, gravity work done is along this length. We could have done from that also. And from here we come to mu is equal to 2 times 5. Very easy. Now we come to some question with 2 blocks, and some people have little difficulty with 2 blocks, but even this question also fairly straightforward. What is given here? This is the block placed here, and this is the figure is clear. Okay, and here the mu is 0.3, this mu is 0.2. Question is first part, what is the minimum value of force need to apply on the plank to make it move? So this also moment we have to take minimum. Moment is word minimum comes, it means the friction which is acting is already reached its maximum limit. The friction is equal to maximum friction force, yet the acceleration is 0. So which body we'll take here? So all we need to do here, we need to choose which body to be taken as system here. That's the first thing we need to think. And second thing we need to think where all the friction will act and which direction will the friction act. Okay, so minimum force, moment we talk of minimum force, limiting friction, but 0 acceleration. And let's take, if I take 5m mass as a system, but this mass is not going to move anyway. It is connected by string. So if I take this mass as a system, this how it will happen. When I apply this force, compared to the respect to the ground also will tend to move towards right. So here also the friction force between the block and the ground also will be in the reverse direction. And the friction between m and 5m also will be in the backward direction. Because if I see, look at the tendency of this block. When this block moves, as seen from M, this block is moving towards right. As seen from the ground surface also, it is moving towards right. Hence, force acting on the block has to be both leftwards. This is how the friction will act. And this friction also is F1 max. And this will be on the other surface also F2 max. Both are maximum friction. And maximum friction will depend on the normal reaction, N1 here. So what is N1 here? First, I'm talking, what is this one? This is between surface, top surface is this, and bottom surface is this. So when I take friction force here, I need to take N1 here, N1 acting on this surface of contact, and N2 acting at this surface of contact. So what is N1 here? N1 will be equal to mg, and very clearly this normal reaction N2 will be equal to 6 mg. Hence, accordingly, what will the friction force here? Mu times N2 and 0.2 times N1. So when we draw the free body diagram, it's very easy to arrive at F, and acceleration is 0 in x direction. If acceleration is 0, actually this force is nothing but equal to maximum friction force on the top surface plus maximum force on the bottom surface. That's all it is. And if we write this equation, very simple, F will come equal to 0.2 times N1, which is mg, plus 0.3 times of, here this 0.3 times N2, which is 6 mg, right? So that's your answer, which comes equal to 2 mg. And the next part of question was given, what happens if force is made 8 times? If force is made 8 times, so this is the minimum force which is required to make it move, or this maximum force at which still there's no slipping. So if you make it 8 times, fairly simple, the friction force will be same value. If the force increases, we can easily calculate acceleration. Coming to next question, again 2 block kind of question. Here also what we do here, the 2 blocks lying on in contact with each other, and shown here, find the friction force between 2 blocks if coefficient of friction between 2 blocks is equal to 0.5 and ground is smooth. So good thing, we are happy whenever something is smooth, it makes our problem solving a little smooth. Friction makes it a little tougher. So this surface is smooth, so make it a little simpler. So how do we solve such question? Okay. Now there's one approach. I'll deal with this, and this is useful in all 2 or 3 block question. What is the role of the friction? Friction tends to keep the blocks together. So if it is within its capacity, it will remain as one block. If the forces are too strong and it is beyond friction force capability, it will slip. So many questions here, we don't know whether slipping will take place or not. So we cannot straight away write an equation which is valid for all cases. We need to start with an assumption. So what is the assumption we make? We make an assumption that friction is successful. Friction is successful means there's no slipping taking place. And then we verify our assumption is correct or not. So friction tends to keep the 2 blocks together. Let's assume it is correct. So assumption is, yes, assumption is two blocks move together. If they are together, we can take both will move together. Whole thing can be taken as a system. If it can be taken as a system, I can calculate the acceleration. F is equal to ma. Net force is equal to 18 Newton leftwards, and mass is 6. So acceleration of the system becomes 3 meter per second square towards the left. Now we check, okay, we made this assumption. Is this assumption valid or not? How do we check that assumption? Let's see that one. So we have assumed the friction was enough to prevent slipping. Now we check what is the friction required to keep them together. Friction needed to keep the blocks together. How do we calculate the friction needed to keep blocks together? It's fairly easy to calculate. This is how, if I take two blocks separately, this is how the two blocks will appear. This is 2 kg. Its weight is acting 20 Newton. Hence the nominal reaction also is 20 Newton. And it is having leftward acceleration 3 meter per second square. So either taking 2 kg block or 4 kg block, I can calculate if they are moving together, what friction will be acting. That's easy to calculate. So this friction, if it is having acceleration of 3 meter per second square, it has to have a net force of 6 in the left direction. This is already force of 2 Newton in the right direction. It means friction force has to be 8 Newton. We can easily calculate from here. The friction force needed to keep these two blocks together is 8 Newton. So if mu value was not given, what are the friction force acting if they are moving together? 8 Newton. Now we check 8 Newton is what is required. But we need to know what is the maximum friction force which is possible here. That's where the assumption checking comes. So how do we check assumption? We calculate friction required and we compare friction divided with maximum friction. If maximum friction is greater than maximum friction required, it means our assumption is correct. No slipping will take place. But if friction required is greater than maximum friction, it means the friction force will not be able to prevent slipping. This because assumption was wrong. It is slipping will take place. And if the slipping takes place, two of them will have different acceleration and friction will be equal to Fk. This is the broad approach. We start assumption, they move together, calculate what is the friction required, compare with maximum friction. What is maximum friction? It's easy to compare. Normal reaction is 20 and coefficient of friction is 0.5. Maximum friction is 10. So friction required is only 8. So it is within the capacity of the friction force. Hence the blocks will move together. And if the blocks are moving together, which friction will act? Will the maximum friction act or only to the extent necessary to prevent slipping will act? Only slipping, what will, that's a self-adjusting nature. If the friction force required to prevent slipping is less than maximum friction force, it is will be in the static state. And in static state, it is self-adjusting. It will act only to the extent necessary. How much friction force will act in this case? Friction force acting will be of 8 Newton. That's a magnitude of friction force which will act here. And you can check here also. Here also we could have calculated whether we calculate friction force required from FBD of 2 kg block or 4 kg block. Both cases will come same. Only friction will act only to extent necessary to prevent relative motion, which is 8 Newton. Okay. Yeah. So we proceed further. Some more variation of similar questions. Look at this question also. I think all the information there in the figure. Mass, there are two blocks, and both the blocks are kept on a smooth surface. Again, we'll be a little happy. The surface is smooth, makes task a little simpler. And mu value between block A and B is equal to 0.2. And this force is applied on the lower block. Okay. So what we need to calculate here, what is the frictional force exerted by A on B? See, can we calculate here? See, what you need to understand here, if we know the slipping is taking place, then I can directly calculate friction force will be equal to mu times normal reaction. But if we are not sure whether slipping is taking place or not taking place, friction force can be anything between 0 to F max if it is in a static state. That makes it a little challenging. That's why we need to start with some assumption. And we check whether assumption is valid or not. We'll start with similar, let's do that once. Again, we start with the assumption that yes, friction is successful. It is able to keep the blocks together. If it is able to keep the block together, then acceleration of the system should be equal to acceleration of block A, should be equal to acceleration of block B. So what we do, we calculate system acceleration. For system acceleration, we calculate what is the friction force which is required or which must be acting for system to move together. And then we compare with maximum possible friction force. And if it is less than maximum friction force, it's a reasonable correct assumption. If not, assumption is not correct. And if assumption is not correct, then also task is simple. Then friction force is equal to Fk. Even then we get to know what the friction force is. And if assumption is not correct, two blocks will have different acceleration. This approach, let's do it again. Very similar to the previous question. So what is acceleration of the system? If we take the whole thing together, the friction force becomes internal force. In this case, external force is 10 and mass is 3. So 10 by 3 is the acceleration towards right. Okay, that's what. Now we take one block here. Then only to have friction force coming into my equation, I need to take a boundary which is passing through the surface here. So either I have to take 1 kg block or 2 kg block. I have taken 1 kg block. The 1 kg block will have a normal reaction of 10 Newton, which is not relevant here because we are only concerned acceleration is happening only in x direction. So since acceleration is here, we applied a force here. So which direction the friction force will act on a 1 kg block? In the forward direction. So if you want to think why the friction force will act in the forward direction, assume that there was no friction. This car would have stayed here. This car would have moved forward. Okay, so this move. So if you view from what is the friction B will apply on A, will depend on how would motion of A appear from B. The friction force applied by B on A depends on motion of A as seen from B. As seen from B, A is falling backwards. Hence, friction force will act in the forward direction. Second way to understand what is happening if you apply this force here only B will getting accelerated, A is not getting accelerated, which is not like the friction. Friction is very democratic, very communist in the approach. He wants to make sure everything shared equally. So this acceleration is lower and this is higher if friction was not present. So what it does, it opposes this acceleration, makes it smaller, and increases acceleration of this. So this is a direction of force. We can work out direction of force in multiple ways. You think of whichever method suits you best. So this direction of friction, we can easily calculate. Friction force required to keep the blocks together is equal to MA by 3 Newton. Now I compare the next part. This is friction required. But is this kind of friction possible to act here or not? Is our assumption valid or not? So to we check Fmax. What is Fmax here? Fmax is equal to mu times normal reaction. So 0.2 times 10. Fmax is only 2 Newton. This is 3.3 Newton. It means our assumption was incorrect. The two blocks will not move together. So how do we solve now? Now we have to solve. We cannot take them as a system. I will take A block separate, B block separate, draw the free body diagram and calculate acceleration of A and B. But now I know since the slipping is taking place, friction is equal to kinetic friction. Slipping will take place and which friction will act? Kinetic friction. Hence here mu S and mu K are not different. Otherwise I would have written mu K times N. So here also friction which will act will be 2 Newton. So what will be the free body diagram? Now I'll calculate for A block to calculate acceleration. Sorry, this part is not there. So this force will act equal to 2 Newton. If this is 2 Newton, acceleration will be equal to 2 meters per second square. So top block will have acceleration of 2 meters per second square. And then when you come to the lower block, what are the forces acting? Newton is acting here. Friction force is 2 Newton acting in the backward direction. Net force is equal to 8 Newton in x direction on a mass of 2. So this will have acceleration of 4 meters per second square. So both will have unequal acceleration and we can calculate. And those who are not followed, go through that question once more, see that it is well understood. This is very common applications and you should be thorough with the same. So if you go to 2-3 times, I think it will sink in your mind. So what we notice another point what you can note, we have done it earlier also in case of question of a suitcase and conveyor belt. The top block, there's no external force acting on the top block. The top block force is applied only in the lower block. So when no force is acting on the top block, it will get accelerated only if the lower block or surface is moving. So top block, no external force is acting, but if it is kept on a surface, if surface is given an acceleration or lower block is given acceleration, this block also will get accelerated. But which force is causing acceleration of the top block whenever lower block moves? Friction force. Only force which is accelerating top block is a frictional force, and friction force has a maximum limit. Hence, there is a maximum limit of acceleration of the top block. What is the maximum acceleration the top block will have? A maximum acceleration the top block will have equal to mu g. The maximum friction force is mu mg, hence maximum acceleration is mu g. So top block, and whenever slipping is taking place, acceleration of top block automatically becomes mu g. So it cannot have, if no force is acting on a block which is placed on the surface or another block here, is maximum acceleration is limited to mu g. So what does it mean? If I tend to move the whole system with an acceleration less than mu g, no slipping will take place, static friction will act. If I make this two block system, if I try to accelerate with an acceleration greater than mu g, in that case, this will have only acceleration mu g and slipping will take place. Now come to next question. In this question, what is the difference compared to previous question? Previous question, the force was applied on the lower block. Now force is applied on the top block. Now only the, now which block is feeling a little cheated? The block B. Now it has no force. It has to rely only on the friction force to get accelerated. So what we notice, whichever block does not have any horizontal force acting. We are talking about all horizontal surfaces. So this block, two block, there's no force which is accelerating in x direction, no external force. So only force which can accelerate is friction force. And since friction force has an upper limit, hence acceleration of B also has an upper limit. That's what, again, similar thing will come to that. What is the maximum value of F? So that blocks do not have relative motion. Blocks do not have relative motion case makes solution pretty simple. If they do not have relative motion, I can take them together as a system. So together as a system acceleration, if I take them together, whatever acceleration they have, if I take them separately also, they will have same acceleration. So this is a condition I'm going to use to find solve. Okay, limiting friction, no slipping. In this case, what will be the acceleration of block B? Because here is easy to calculate acceleration of block B. Because the force which is trying to move is frictional force. And whenever we talk about maximum value, the friction force is already at its maximum. Moment we talk about maximum, so what is maximum friction force on this block? Which surface friction force acting on this surface? So I have to calculate what is the normal reaction in this surface. Normal reaction is 10 Newton, and hence mu value is 0.5. So friction force is equal to 5 Newton, and this only force which is accelerating. So this acceleration will be equal to 2.5 meter per second square. So, and B cannot have it. So this is the maximum acceleration of B. Hence, the system maximum acceleration also should be equal to 2.5 meter per second square. Then only they move together. Okay, so this is maximum possible acceleration of B. Hence, maximum acceleration of system also has to be equal to same. Only force causes acceleration is friction. Maximum acceleration when maximum friction force is acting is 2.5 meter per second square. The system also should have same acceleration of 2.5. Now I calculate system acceleration. What is system acceleration? System acceleration will be F by 3. And that's only external force. That has to be equal to 2.5, which gives me the F value is equal to 7.5 Newton. Okay. So this is the last question. I'll quickly deal with this. So just think of it. There's a truck and you would have seen, see, whenever a car suddenly accelerates, if anything lying on the floor, it tends to slide backwards. Let's try and understand why does it happen. So there's something like rear side of truck. So there's a truck body and truck is open and box of mass of 20 kg. There's a box here, mass of 20 kg, is kept at a distance of 4 meters away from the rear end. This distance is 4 meters. It kept at a distance of 4 meters. And truck starts from rest with an acceleration of 2 meters per second square on a straight road. So when truck accelerates, it means the body of the truck, the surface of the truck will have an acceleration of 2 meters per second square. That is one complete one object. But it doesn't mean the box also will have same acceleration. And you notice in the case of train also, when you suddenly apply the brake, what happens? It tends to slide. Why it tends to slide? Again, we'll try to understand here. So this force mu is equal to 0.15. If mu is equal to 0.15, as this surface tries to accelerate, friction tries to accelerate box also. But friction has a maximum limit. And so what is the maximum frictional force which can act? Mu mg. Hence maximum acceleration of B is equal to mu times g. So maximum acceleration of, since slipping is taking place, kinetic friction will act, acceleration will be maximum. So acceleration of B, block B, if I take separately box, only force acting in all direction is Fk, kinetic friction, because slipping is taking place, and kinetic friction is equal to mu k times mg. Hence acceleration of B is equal to mu k times g, and that is equal to 1.5 meter per second square. So this is having 2 meter per second square, this is having 1.5 meter per second square. So what is the distance truck will move before this block falls off the surface? So one way of thinking would be, if I attach a observer here, if you are standing at this point on the truck, what you see initially, you see this block B is at the same position 0. When it falls off, its displacement in x direction in the frame of reference of the truck has to be equal to 4 meter. With reference to the truck, it must have a displacement of 4 meter. So one is again this question of relative motion. So as seen from the frame of truck, what is the initial velocity of B? Both start from rest, initial velocity is 0. But what is the acceleration of B? As seen from the truck, truck has 2 meter per second square, this has 1.5. It is equivalent to this having an acceleration of 0.5 meter per second square. Okay, so this and how much time does it take to travel a distance of 4 meter? We can easily calculate time it will take to calculate a distance of 4 meter. S is equal to 1 by 2 AT square. So 4 is equal to 1 by 2 into 1 by 2 into t square. And what we need to calculate, distance moved by the truck before the box start to fall off. Once we have this time t, we can also calculate how much distance the truck has moved. And you notice here, we can have answered this question even without all this calculation. So this is the time, t is equal to 4 seconds. In 4 seconds, it will fall off. And what distance the truck will move in time 4 seconds, distance moved by the truck will be equal to 1 by 2 acceleration of the truck into 4 square. Acceleration of truck is 2 into 4 square. It will move a distance of 16 meter. And we could have travel otherwise also. This has acceleration of 0.5. If this has to move a distance of 4, this acceleration is 4 times. So this will have 4 times that displacement. So it will be 4 times the length of the truck, 16 meter, is the distance truck has to travel before it falls. So that is all for today. I think all